At 1,000 yards, the argument came down to two numbers: about 4.8 inches of armor penetration from the American 90mm M3, against roughly 3.9 inches of near-vertical armor on the front of a Tiger I. For most of the war, American crews had lived on the wrong side of that equation. Then the M36 arrived, and for the first time, an American tank destroyer did not have to beg for a flank shot just to make the range fair. That does not mean the M36 turned every German heavy tank into an easy kill. It did something more important. It changed which crew could afford to fire first. Before the M36, the American tank destroyer force already had speed, organization, and a doctrine built around rushing anti-tank power toward a breakthrough. What it lacked was a gun that stayed dangerous after the distance opened up. The M10 carried the 3-inch M7. Against older German tanks, that weapon was useful. Against a Tiger from the front or a Panther in the wrong place, it became a weapon of conditions. Get closer, find the side, catch the turret, wait for the angle. Every one of those conditions gave the German crew more time to see you, range you, and fire first. And that was the hidden problem. The M10 was not simply undergunned. It was undergunned at the exact distance where its thin armor made distance essential. The Tiger I carried about 100 millimeters of frontal hull armor, almost vertical. Its 88mm gun could punish an exposed tank destroyer long before the American crew wanted to close the gap. The Panther made the geometry worse. Its upper glacis was only 80mm thick in raw steel, but it was sloped at roughly 55 degrees from the vertical. That slope forced an incoming shell to travel through a much longer path of armor. It also encouraged the shell to glance away. A plate did not have to become physically thicker to behave thicker. It only had to make the projectile arrive badly. American crews saw rounds strike cleanly, flash, and vanish upward. A hit on paper, a ricochet in reality. So crews compensated with tactics. They used multiple vehicles. They maneuvered for the sides. They pulled German armor into ambushes. They fired smoke, shifted positions, and tried to create the shot their gun could actually finish. That was skill, but it was also a confession. The weapon could not solve the target from every angle. The Army had built the tank destroyer branch around the idea that enemy armor would mass for a breakthrough. American tanks would exploit. Tank destroyers would hunt. The anti-tank force would stay mobile, concentrate quickly, and strike the armored spearhead before it could widen the breach. On paper, the logic was clean. In practice, the branch was split by an argument over what mobile really meant. One side favored towed guns. They were cheaper, easier to hide, and deadly from a prepared ambush. The other side wanted the gun on tracks. A self-propelled weapon could change firing positions, withdraw before artillery found it, and move with the crisis instead of waiting for the crisis to arrive. Combat did not settle that debate politely. It settled it with abandoned guns. Once a heavy towed piece fired, every enemy observer knew where it was. Moving it under shell fire required a crew to leave cover, handle the trail, bring up the prime mover, and pull out along a route that might already be under fire. A self-propelled vehicle could fire, reverse, relocate, and appear somewhere else. In the Ardennes, where roads were blocked, units were scattered, and German armor kept changing the direction of the threat. That difference became survival. The M36 entered the war on the side of movement, but its real achievement was not the hull. It was what American engineers managed not to redesign. They kept almost everything that already worked. The M10A1 already existed in numbers. Its hull, automotive system, suspension, tracks, and turret ring were proven. Instead of building an entirely new vehicle, engineers created a larger open-top turret that could accept the 90mm M3. The standard M36 used converted M10A1 hulls. The M36B1 placed the turret on an M4A3 Sherman hull. The M36B2 used M10 hulls. Different bases. One answer: a 90mm gun on a chassis the Army already understood. That shortcut mattered because a new turret was faster to field than a new armored vehicle from the ground up. The M36 was standardized in 1944, and the 703rd Tank Destroyer Battalion began converting at the end of September. By October, the gun was in combat. The timing could hardly have been tighter. The weapon itself had roots in American anti-aircraft development. Like the famous German 88, the American 90 was born from the demands of firing a heavy projectile at high velocity. Anti-aircraft work rewards speed, flat trajectory, and powerful ammunition. Those same qualities make an excellent anti-tank gun. Adapted into the M3 tank gun, the 90mm fired the standard M82 armor-piercing cap projectile at about 2,800 feet per second. The complete round weighed more than 40 pounds. That mattered inside the turret. This was not a gun fed by effortless machinery. A loader had to grab, lift, align, and ram each round while the vehicle moved. The turret turned, and the crew listened for the next incoming shot. The gun was also selected for the T-26E3, the tank that would enter service as the Pershing. So before the Pershing appeared in meaningful numbers, a vehicle built from tank destroyer hulls was already carrying the same main armament toward the front. The M36 was not a heavy tank, but it arrived with a heavy tank's gun. Now the equation changed. U.S. firing data for the M82 gave it roughly 122 millimeters of penetration at 1,000 yards against homogeneous armor set 30 degrees from the vertical. That is about 4.8 inches. Against the Tiger Eye's near vertical 100 millimeter front, the 90 finally gave American crews a realistic head-on solution at ordinary combat distance. Not a guarantee. Armor quality varied. Angles changed. A moving target is not a firing table target. But the gun had crossed the threshold that mattered. A Tiger could no longer assume the American round would simply fail because the range was long. That changed behavior on both sides. An M36 commander could hold a firing position farther back. The gunner could use the distance. The driver could keep the hull behind cover. The crew could wait for the shot instead of rushing forward to create one. The enemy now had to respect the American sightline. That is what a better gun buys first. Not kills, options. The Panther remained the more complicated target. Its upper glacis still defeated the standard M82 under many conditions. The January 1945 Ordnance Ammunition Guide was blunt about the limit. With standard ammunition, the Panther and King Tiger still had frontal areas the M36 could not reliably penetrate, especially the glacis. That matters because the popular version of this story often turns the 90mm into a magic wand. It was not. The Panther's front hull was still a geometry problem. The M36 did not erase geometry. It gave the crew more places where geometry could be beaten. The turret front, the lower nose under favorable conditions, the side armor, the rear, the brief moment when a Panther turned to engage another threat, the moment a slope became less severe because the ground tilted the hull. A powerful gun does not remove the need for tactics. It expands the number of tactical mistakes the enemy cannot survive. There was ammunition that could push the equation farther. The T-30E16 high-velocity armor-piercing shot used a tungsten carbide core and left the muzzle at roughly 3,400 feet per second. Against difficult armor, it was dramatically more capable than the M82. Tests showed it could penetrate Panther armor that stopped the standard projectile, but tungsten was scarce. The same strategic material was needed for industrial cutting tools and other war production. The result was a round crews valued precisely because they could not count on having many. A few tungsten rounds in the rack were not ordinary ammunition. They were emergency answers. A crew did not waste one, proving the gun worked. They saved it for the target that standard shot could not solve. That scarcity is part of the M36 story, because weapons are never only barrels and armor. They are also mines, factories, shipping space, production priorities, and the number of special rounds that actually reach the vehicle before the battle begins. A gun may be capable of a shot. A crew may still have no round to take it. Then there was the turret itself, open to the sky. The design reduced weight, gave the crew room to work the large gun, and provided exceptional observation. It also left the men exposed to airburst artillery, mortar fragments, grenades, snipers above street level in winter weather. In open country, the commander could scan without fighting through narrow vision blocks. Targets appeared faster. Orders moved faster. The first shot could leave faster. That was a real advantage for a vehicle whose protection depended on firing first. But in woods, towns, and under artillery, the same open roof felt like an invitation. Crews improvised. Canvas kept out weather, not steel. Scrap plate and field-built covers offered uneven protection. A folding armored roof kit was later developed, but the basic trade never disappeared. The M36 could see the battlefield clearly because the battlefield could see into it. That contradiction defined the whole machine. Its gun belonged in a heavy fight. Its armor did not. The hull front was thin by tank standards. The turret sides were thinner still. A German tank gun was not required to kill it. Artillery fragments, anti-tank weapons, and close-range infantry could do the job. The M36 could not survive a fair exchange of hits. So its crews tried to make the exchange unfair. Find cover. Expose only what was needed. Fire. Move before the reply. Use the turret's visibility. Use the gun's reach. Use the hull's road speed, around 26 miles per hour, to arrive where the enemy did not expect a 90mm weapon to be waiting. By December 1944, those qualities stopped being test data. The German offensive in the Ardennes tore through a thin American front under low clouds that limited Allied air power. Snow and ice narrowed movement onto roads. Units lost contact. Rumors outran orders, and German formations brought Panthers, Tigers, and Tiger IIs into a battlefield where many American anti-tank weapons still needed the perfect shot. The M36 was not everywhere. There were too few of them for that. But where one appeared, it gave the defense something rare. A mobile gun that German heavy armor had to take seriously before closing. The self-propelled tank destroyer could shift with the crisis. It could cover a road, withdraw, and cover another road. It could occupy a reverse slope or a village edge, fire from range, and leave before artillery bracketed the position. That did not make it invulnerable. The Ardennes punished open-topped vehicles brutally. Tree bursts showered crews with splinters. Frozen mechanisms failed. Visibility changed by the hour. Roads clogged with wrecks and refugees. Yet mobility kept the gun in the argument. A towed piece that could not move was a position. An M36 that could move was a threat. A widely repeated account from the 702nd Tank Destroyer Battalion describes an M36 knocking out a Tiger II near Freialdenhoven at about 1,000 yards with a shot into the side of the turret. The important word is side. The Tiger II's frontal glacis was far beyond what the standard M82 could reliably defeat. The 90mm had not made the heaviest German tank fragile. It had made a good flank shot final. That is the honest measure of the gun. Against a Tiger I, it could create a credible frontal solution. Against a Panther, it opened more vulnerable zones and made turret or side hits decisive. Against a Tiger II, it still needed position, angle, and ammunition. The M36 was not an answer to armor in the abstract. It was an answer to specific armor under specific conditions. That is why the machine was dangerous. Its crews knew the difference. The M36 also reveals something larger about American wartime production. The famous strength of the United States was not that every design arrived early or perfect. It was the ability to take a working system, identify the part that had become inadequate, and replace that part without stopping everything else. The M10A1 hull was not thrown away. The turret ring was not reinvented. The automotive system was not replaced simply because the gun was new. Engineers spent their time where the battlefield had exposed the failure, the weapon, the turret, the balance, the ammunition stowage. The result was not produced in Sherman numbers. Across all wartime variants, fewer than 1,800 M36 series vehicles were completed. That was enough to matter, but not enough to be everywhere. The Sherman remained the vehicle that carried the armored war across Europe because it was reliable, supportable, and available in enormous numbers. The M36 had a different job. It was the specialist brought in when ordinary answers had reached their limit. So this is not a story about one vehicle replacing the Sherman. It is not a story about American crews suddenly becoming invincible. And it is not a story about a gun that could punch through every German plate from every angle. It is a story about restoring balance at the distance where balance had been lost. Before the M36, an American tank destroyer facing a heavy German tank often had to solve 3 problems before it could even fire. Close the range, find the angle, survive long enough to use both. The 90mm removed one of those problems, sometimes 2. It let distance become protection instead of punishment. It let a hidden crew wait instead of charge. It let a Tiger I's front become a target instead of a warning. And when the armor was still too strong, the gun made every exposed side, turret, and turning mistake much more expensive. That is why the M36 mattered. Not because it made German armor weak, because it finally made the range fair.